we have been discussing about the scaling laws for designing micro robotic system. In fact, we have discussed a lot about the different configurations, how we scale up, how we scale down the system, that is from a macro to micro level, how does the system behaves. We had some detailed interaction about the rigid body dynamics as far as with reference to micro robotic perspective point of view, and we also had some discussion about this usage of this electrostatic actuation for micro robotic related application, especially the fundamentals of these electrostatic actuation towards micro robotics development. Now we will discuss about the scaling in an electromagnetic force. So as far as these electromagnetic forces are concerned, it plays a vital role in micro robotic application. So in order to, the key motivation in considering these electromagnetic forces is, most of you might have aware about this origami based robots. So when these origami based robots are concerned, so these origami based robots take up a kind of a reconfigurable shape based on the type of application what we are looking for. For example, you have a kind of a tube. So inside the tube, so you want to make a kind of a structure. So these structures gets reconfigured and it tries to roll into the tube so that it can be used for inspection, or it can be used for cleaning, or it can be used for a complete structural analysis, etc. Now, as far as in this particular scaling in electromagnetic, when we try to consider into the electromagnetic actuation, so it can be effectively used for shrinkaging a micro robot. For example, if let us consider this as a tube, and we have a robotic structure which has a petal type, something like this. Now, when we try to supply an appropriate actuation to it, it gets thinned and then it tries to move into the system. So, so what happens is this structure can easily get contracted and it can easily pass through the tube for appropriate movement. Okay. Now, in order to, so here electromagnetic plays a vital role in bringing a macro system to a micro system. It also has a capability towards locomotion perspective point of view. So in order to have a precise locomotion, or in order to have a kind of a micron locomotion, such kind of electromagnetic forces play a vital role. So like as discussed, unlike macroscopic system where gravity is dominant, these electromagnetic forces become substantially stronger at small scales. When we look into these electromagnetic forces, the fundamental behind these electromagnetic forces follow a fundamental physics law that determine how they scale a size of an object. So which is considered to be one of the key functionality which we will be taking it up for the micro robotic design or development. So when we look into the charges of these scaling laws, if an object's surface area scale as k square, then the total charge it can hold, assuming a constant surface charge density, also scales, which we can represent it as q dash equals k squared cube. So the scaling of electrostatic force, which we call it as a Coulomb law, these electrostatic force between two charged particle is given by this Coulomb law, F equals k q1 q2 by r square. If the charge scale has k square and the distance scale has k, the force can be represented as F dash equals ke k square q1 by k2 q2 by kr square. So if we try to simplify it, we can represent it as k power 4 k squared fe and k squared fe. So when this is considered to be the overall governing equation which can be considered for whenever we are trying to consider an electromagnetic force or electromagnetic actuation for micro robotic device development. So when we what is the key motivation of considering this electromagnetic scaling? These electromagnetic scaling highly matters in micro robots. So one of the applications which we have discussed, some of the key salient features of considering this electromagnetic scaling factor is, since electric and magnetic force dominate at small scale, so the gravitational force becomes negligible and the electrostatic and the magnetic actuators work efficiently. Next, with reference to charge perspective point of view, energy management in a micro robotic system is considered to be one of the key challenges which needs to be addressed. In fact, people are attempting different types of methodologies. In our lectures also, we will be discussing more on such kind of power management for micro robotic systems, how those problems are addressed. So, miniaturization limits the onboard batteries into the system. So there is a need to go for an inductive, capacitive, wireless charging method, which are considered to be crucial. Now, when we consider the optical and quantum effect based system, these optical and quantum effect becomes a significant, especially when we try to consider a plasmonic effect and a photonic interaction, which basically influence the micro robotic communication. In addition, there is a kind of a quantum tunneling and Casimir forces, which may also become a kind of a relevant system for a micro robotic application perspective point of view. When we look into the application of these electromagnetic scaling in micro robots, these electromagnetic actuation, which is used in a MEMS, which is highly used in MEMS based micro robots, with reference to magnetic micro robot perspective point of view, one of the key advantage of using these magnetic based micro robot is it can be remotely controlled by external magnetic field. For instance, so this is a kind of a micro robot which is used for a kind of a targeted drug delivery. So in this micro robot, in order to cater the locomotion or in order to cater the movement, so we can effectively use an electromagnetic system for an appropriate resolution. Next is with reference to optical tweezer perspective point of view. So optical tweezers are considered to be one of the efficient system which is effectively used for micro robotic related applications. In fact, in our entire series, so we will be discussing about something on optomechatronic systems, how these optomechatronic systems are effectively used for developing micro robotic structures, light driven micro robots. In fact, I will also be discussing about these light driven micro robots, the overall functionality and fundamentals of these light driven micro robots in detail. So when we look into these optical tweezers, it is used for trapping, and the main fundamental behind usage of these optical based micro robots, optical actuated micro robots, is if we try to integrate a nanoparticle along with the structure, appropriately we can actuate the system. Next, we can talk about the wireless power transfer. Of course, this is where exactly the inductive and the capacitive charging for untethered robots comes into the picture. Next, which we had discussed about it, is a kind of a plasmonic nanorobot, which talks more about the use of light matter interaction for the movement. In fact, in this particular structure, this is a kind of a small micro robot where there is a kind of a small gripper kind of arrangement is attached to it. The actuation of this gripper are highly through an electromagnetic structure, so that we can have an appropriate coil over here. By applying an electrical field or by applying a magnetic field, we can have a precise manipulation in this particular system. Now, one of the key aspects which we have addressed over here is more to do with micro manipulation, more to do with micro locomotion, and it also takes care of the power transfer also. Now, in addition to this, adhesion also plays a vital role. So when we try to look into the adhesion perspective point of view, as we had discussed earlier, so a part of locomotion will also be considered for an adhesion, because consider a gecko based robot, which is a kind of a lizard based structure which is trying to walk on a wall. So what happens is there is going to be a suction or there is going to be an adhesion with an actuation which will be helpful for an appropriate movement in the system. Now, as far as this nature of adhesion for these micro robots are concerned, so there are 4 different forces which are being exhibited over here. One is a kind of a van der Waals forces. Next is a kind of an electrostatic forces. Third is a gravitational forces which exhibits to the system. Fourth is the surface tension which exhibits on this particular aspect. Now, as far as electrostatic, we had discussed a lot. Gravitational forces, we are more aware about it, and in certain cases it needs to be overcome either through electromagnetic or through electrostatic. With reference to van der Waals perspective point of view, one of the important aspect is these van der Waals forces are present in all the materials, which results in the kind of an interaction between an instantaneous dipole moment of atoms. So when we try to closely observe the overall fundamental behind these van der Waals forces, it goes like we can classify these van der Waals forces into three categories. One is called as a key-sum force. So these key-sum force, basically it relates the angle average dipole and the dipole interaction between two atoms or molecules. Next, when we try to talk about the Debye force, so this Debye force is the angle average dipole which induces a dipole interaction between two atoms or molecule. Next, we have the dispersion force. So these dispersion force basically contribute to the van der Waals forces, which relates to the instantaneous dipole which induce dipole interaction. The force of quantum mechanics in nature acts as a distance which is more than a 10 nanometer to 2 Armstrong. So basically, from the micro robot, overall adhesion actuation capability will lie in the nanometer domain, so which will result in a kind of a like interaction. So ideally, if you see in the system over here, there are certain amount of microfibers. So this basically corresponds to a locomotion mechanism of a gecko inspired climbing robot, so which we'll be discussing in detail when we come to this bio inspired based robots. So in this gecko inspired climbing robot, so we have certain nanofibers, so we have microfibers and a micro and a nanoscale based structures. So these nanofibers have a complete control over the adhesion. This is where exactly the van der Waals forces place. So ideally, all these forces will contribute towards this movement or towards this locomotion. So if we look into the overall configuration of the force which is being derived, so when we try to look into the potentials which are being derived from these forces, it can be represented as UDW, which is minus CK plus CD plus CL by R6, where these three parameters represents the CK represents to the key sum, and the Debye force represents CD, and the dispersion force corresponds to the CL. So this is how basically such kind of adhesion forces are taken into consideration. Now, whenever we are trying to design these micro robotic structures with reference to an adhesion forces, this plots help us to design the structure based on our requirement. So ideally, based on the diameter or based on the size, appropriately we can and when we know how much force which will try to integrate or which will try to fall on the surface, so based on that the relations can be appropriately taken from this plot, for which will be highly useful whenever we are designing the system. Now let us talk about let us have a brief overview about the scaling in electricity. So as far as electricity is concerned, so electricity at a micro scale, it follows a different scaling law compared to the macroscopic system. So as object becomes smaller, properties like resistance, capacitance and inductance scale differently, which affects the performance of microelectronic circuits and the micro robots. So when we consider a micro robot, of course there is a need to have a kind of an electrical system, a kind of a micro electrical pulse which needs to be integrated into the system, and these micro electrical pulse will be effective enough to create an appropriate micro propulsion system. Some of the scaling laws which are related to the electricity may be derived from a simple laws which is shown over here. Like if you try to look into the parameters, so we have the electrical resistance, the resistance power loss, and the electric field energy. So in addition to this, we also have the capacitance and the inductance. Now if we closely observe the influence of this inductance and the capacitance, let me just introduce you to the different common parameters which are being deployed. I think most of you are aware about these common parameters. Some of the parameters which includes the rho, which is the electrical resistivity of the material, L and A, which corresponds to the length and the cross-sectional area respective to the conductor, P is the applied voltage, epsilon is the permittivity of dielectric, E is the electric field strength, D is the separated distance, mu is the permittivity of the core, N is the number of turns in the coil, and L is the length of the coil. Now, why do we require this electrical scaling matters in micro robotic system? So we may need to consider the following parameters. One is with reference to power efficiency and heat dissipation. As the circuit gets smaller, there is going to be a higher resistance and increase in power loss. It is highly useful for managing heat dissipation, is crucial in microprocessors and microactuators. Now with respect to signal integrity perspective point of view, signal integrity in microelectronic perspective point of view, it has a lower capacitance and inductance effect. It has a signal propagation and filtering. It is mainly meant for making high speed communication, which is a bit difficult. Now with reference to breakdown voltage and reliability perspective point of view, it has a miniaturized circuits which are more vulnerable to electrical breakdown, and it requires a stronger dielectric materials. One of the key aspects is with reference to micro-robotic actuation and energy storage, where we have the electrostatic forces which dominates a small scales, influencing a micro-robotic movement. A miniaturized battery stores less energy, so these micro-robotics rely on the wireless power transfer. So when we try to look into the applications of these electrical scaling in micro robotics perspective point of view, so we have an electrostatic actuator which is used in MEMS and micro robots for precise motion. Then there are a certain amount of microelectronics which are kind of a small scale capacitors and inductors which impact the circuit design. Then we also have the energy harvesting, where micro robots use an inductive and a capacitive power transfer which are being exhibited. Biomedical devices, where microscale sensors and implants rely on the low power electronics. As far as these fundamentals of the scaling laws in electricity is concerned, so if we try to map the electrical property with reference to the scaling size and the scaling effect, the electrical resistance which are represented as k power minus 1, where the resistance decrease with reference to miniaturization. Now with reference to resistance power loss perspective point of view, it is represented as k power 1, which is like it increases and it affects the circuit efficiency. The electrical field energy perspective point of view, which is represented as U, which is k power minus 2, which decreases. And with reference to capacitance perspective point of view, which is represented as k power 1, the capacitance increases with miniaturization. With reference to inductance perspective point of view, k power minus 1, the inductance decreases, limiting the electromagnetic energy storage. So to summarize, like we have been discussing about the electromagnetic based systems, scaling laws of electromagnetic system, how these electromagnetic systems are effectively used for different micro robotic design or micro robotic perspective point of view. So we also have some discussion about the electrostatic actuations, how these electrostatic actuations are deployed and how it is being effectively used for different applications. The adhesion force in micro robotic system, it's a separate study. There are different adhesion forces which are being participating whenever we are trying to design these micro robotic structures. So if we try to classify these adhesions, so we have the van der Waals forces, the electrostatic forces, the gravitational and the surface tension, which plays a vital role. Now when we try to classify these van der Waals forces, we have the Keesum forces, the Debye forces and the dispersion forces which exhibits. Now electrical related aspect with reference to microrobotics, it is highly challenging. There is a need to understand the phenomenon of scaling of this electricity, how what are the parameters which are involved with reference to electric perspective point of view, and how does it behaves when it comes to a miniaturized level. So with that aspect, if we look into it, so we have summarized in such a way that with reference to different parameter and in the scaling effect or in the micron domain, how does these miniaturizations will have an impact on the different parameters. So appropriately, these are some of the points which we may need to take it up whenever we are trying to design a micro robotic system. Now we will discuss about like we have been discussing about the different parameters. One of the key aspect of a micro robotic system is, let us consider like we are in the process of developing a micro robotic system for a biomedical related perspective point of view. So we are focusing on some kind of targeted drug delivery. So in that aspect, so there is a need to for these micro robots to interact with a fluid medium. So how does it behaves in a fluid medium, and what are the parameters which has an impact on this fluid medium? Let us discuss. Now with reference to fluid domain perspective point of view, there are different biomimicking based micro robots which have been developed. In fact, this we will be discussing in the and at the different modules, how these biomimicking based micro robots are developed, and how the locomotion is exhibited on these biomedical robots, and how it has been deployed for different applications. Just to give you an overview, so like when we try to consider a fluid domain, so these are some kind of micro robots which are developed by considering a biomimicking nature. Like one is this helical micro robot with a soft magnetic head, so that by applying a magnetic field, and since there is a helical moment is there, so by applying a magnetic field, this helical moment will catalyze the overall movement of these structures, and then we can have a locomotion. Then we have a kind of a flexible tail oscillation. So as far as in this flexible tail oscillation concerned, it's a kind of a sperm based actuated micro robot, like it almost mimics a sperm moving in a fluid domain. So here there is a flexible tail with the oscillation, so the movement of the oscillation will cater the locomotion. It also has a potential application in targeted drug delivery. Next we have the Celera based micro robots. So this is the overall schematic of the Celera based micro robot. So it almost inspired by the micro robotic structure called Celia. So if we closely observe how these system moves either in a blood domain or in a fluid domain or any other liquid domain to take care of the functionalities, so there is a need to understand the different parameters which exhibits. So as far as this fluid mechanics is concerned, so fluid mechanics, like most of you might have studied fluid mechanics, so these fluid mechanics play a crucial role in micro robotics. As the behavior of the fluid changes drastically at small scales, forces such as viscosity, surface tension and drag becomes a dominant, while inertia and turbulence become negligible. So ideally, if you look into the configuration of a fluid, so the shear deformation of the fluid can be appropriately categorized into two. One is called as a stationary fluid structure, another one is called as a displaced fluid structure. So as far as these stationary fluid structure is concerned, so it has it dominates in a particular domain, and in the case of a displaced fluid structure, so let us consider you have a kind of a oily layer which tries to get displaced. So some of the key parameters of this fluidic structure is governed by this velocity profile, which has a direct intervention towards volume of moving fluid. So in that particular aspect, so we have a velocity profile in place. This is the overall area and a shear stress which is being induced into it, and then there is a non-slip boundary which exhibits over here. Now, like most of us are aware about this Reynolds number. So these Reynolds number RE, which basically takes care of the flow behavior. So there are different parameters which caters these Reynolds number. One is the rho density, which remains constant. V is the velocity, which usually scales as K0 or K1. L is the characteristics length, scales as K, and mu is the viscosity, which remains constant. Now, this figure gives us a kind of a clarity about the different types of fluids, which are different types of class of fluids which are being available for the actual applications. One is a kind of a plastic base, another one is called as a dialant base, then we have the Newtonian fluid and the pseudoplastic system. So the selection of these fluid is decided by this shear stress and the shear strain rate. Now let us consider this drag force. So the drag force is given by the equation Fd equals CD half rho v squared A, where the cross-sectional area A scales as k squared and the drag coefficient Fd is it is mentioned as Fd. Similarly, there is a velocity squared which you call it as v squared, which is scale at k0 or k squared and at density rho, and it is governed by the equation Fd dash equals CD half rho k squared v squared k squared A, which can be appropriately represented as k squared Fd. As far as these viscous force are concerned, so when we try to look into the viscous force scaling, so the viscous force is given by the F equals micro A dV dy. So where we have the surface area scales as k squared and the velocity gradient which is represented as dV dy as k. So it can be represented as F dash V, which is the K of Fv is considered to be the final equation with reference to the scaling, viscous force scaling. Similarly, when we try to look into the other parameter which is called as a surface tension scaling. So these surface tension scaling has a direct relevance towards shear as well as the length scales as k, which is represented by this particular equation. And the capillary number scaling is concerned, the capillary number scaling is given by Ca equals micro u by sigma, so where micro is considered to be the dynamic viscosity, velocity u which scales as k power 1, which is considered to assumed to be similar kinematic, and the surface tension is concerned, the sigma remains constant or scale as k0. So this can be represented as Ca, which is inverse of k1 by k0 or k1. Now when we look into the influence of these scaling laws in the fluid mechanics perspective point of view, so let us take out the different fluid property. So one of the fluid property includes the Reynolds number, the drag force, the viscous force which is represented as Fv, the surface tension which is represented as Fs, and the capillary number Ca. So the scaling with size can be represented as K1, which is the scaling effect is low Re viscous dominant at small scales, and then in the case of a drag force, the drag dominates, which is affecting the micro robot movement. As far as viscous force is concerned, these viscous force increases, which is preventing the free motion. And surface tension perspective point of view, these surface forces they dominate and it also affects the locomotion. When we look into the capillary number, this capillary effect remains significant even at small scales. Now, when we try to correlate the fluid scaling matter in micro robotics, see, these micro robots cannot move like macro robots. So these traditional swimming high Re does not work and requires a low Reynolds locomotion like we have seen the cilia or flagella based motion. Similarly, when we try to talk about the visco-dominate over inertia perspective point of view, these micro robots, when they try to move in such kind of liquid domain, they experience a high drag and resistance. In fact, this also has a direct impact towards the power consumption perspective point of view. So there is a need to go for a specialized automation. So that is what we have seen in our first slide also. So there is a need to go for a helical rotation or a peristaltic rotation in the system. So appropriately having an helical rotation or a peristaltic rotation, we can save the overall power consumption, and because of the movement of this helical or a peristaltic, we can have a control over the resolution of the locomotion what we are looking for. Okay, so in fact helical rotation is the one what we have seen over here. So this is a kind of a helical rotation which exhibits, it's a kind of a corkscrew rotation which exhibits, which will have a direct control over the locomotion what we are looking for. Okay. Next is with reference to capillary and surface effect perspective point of view. These capillary and surface tension effects are strong. The water surface behaves like a kind of a soft elastic membrane for a small objects, and these micro robots needs to exploit surface interaction for mobility. So even for a micro mobility or a minor mobility, these kind of capillary and the surface tension effects are deployed. Now, with reference to the usage of these micro robots or the application of fluid scaling in micro robotics is concerned. So first let us consider the swimming micro robot, which uses a kind of which moves using a cilia or flagella or helical motion at a low Reynolds number. These microfluid used in a lab on chip device for biomedical application. Now, with reference to surface adhesion robot perspective point of view, it exploits the surface tension and the capillary forces. And the biomedical robot perspective point of view, these biomedical robot navigate through the blood cells and tissues using the fluidic force. So ideally, we have a kind of like a micro channels. Through these micro channels, such kind of biomedical robots can be actuated, and it has a potential application in the case of a fluidic scaling. So overall, in this particular module, we had discussed about the electromagnetic forces, how these electromagnetic forces are contributing. So we also had some discussion about the adhesion forces. So we also had some discussion about electricity, scaling laws of electricity, how these different parameters of electrical system behaves in the micron level, and how it can be. So this will give us a clarity that how we can deploy this electrical system for an efficient design of a micro robot. And then we had some overview about the fluid domain in a micro robotic system. So where we have seen some certain configurations of these biomimicking based micro robots, and how these biomimicking based micro robots are helpful for an appropriate locomotion. There are different parameters which exhibits with respect to scaling and fluid mechanics perspective point of view. So in that aspect, so influence of Reynolds number scaling, the drag force scaling, the viscous force scaling, the surface tension scaling, and the capillary number scaling. So when we look into the scaling laws in fluid mechanics, so we have a fluid property in place, the scaling with size and space, and the scaling effect in place. So with reference to the scaling effect, appropriately we can have a interaction with reference to fluid property. So while these fluid scaling matters in micro robots, so like we can have the different parameters which dominates. The micro robot like move in a macro robot, the viscosity dominates, capillary and the surface tension effect. With the reference to application perspective point of view, there are different fluid scaling in micro robotic systems. So like we have taken 3 different examples like this cilia based, flagella based, etc. And with reference to that, how it works upon in the fluidic domain is taken into consideration. Of course, in the future modules, we will be discussing in detail about how it has been directly employed in the field, how design considerations are taken into confidence for developing such kind of structures. The next module, we will discuss about the scaling in heat transfer, because heat transfer play a vital role towards actuation of these micro robots.